So you can think of it now as the developer is assembling his application with a little bit of source code, and then he's deploying it on an OS and adding utilities, and that's what makes up the container. So the developer now has more responsibility for security. So you actually, technologies can have visibility to everything that's going on in the entire cluster, all your containers. And so what the technology, it's not a Twistlock-centric presentation, but what Twistlock has done has applied machine learning to these running containers, basically to build out what I would call automatically build out a whitelisted security model for all of your containers in a cluster, whether it's thousands. Automation is pretty key here. You can think of it, I like to think of it as, I don't know how many here have raised a teenager. So if you've raised teenagers and all of a sudden there's a whole bunch of things going on that are different, that are changed, it's not normal, they're coming in late or on their, you look for like anomalies in their behavior, and there's usually a red flag. So it's the same thing here. You can build out what's normal behavior for all of your containers, and then any activity outside that norm, you want to and you're automating that because you can have a solution that monitors all the containers running. Also, in Andrew's talk, he talked about immutability. So container images are immutable, so they're not going to be changing. Someone's not going to go in and make a change to the container. They're immutable. So a security model for that container So, assuming that you see the value of building out this behavioral model, how do we accomplish that? It's going to have declarations for ports that are open. And so there is a lot of information about the behavior of a running container from the Docker file. So that we call that the static analysis. So what the Twistlock solution does is scans the static image and adds that to the model. And then when the of this container can be modeled out through machine learning. The beauty of all of this is you need to do this automatically. If you remember, Google has 30,000 deployments a day. If you don't have a solution that automatically does this, it's not going to work. You can't have your cake and eat it too. What threat analysis is finding, basically detecting any malware that comes into any of those containers or the host they're running on. So if someone downloaded a ransomware program or a virus or a worm, you want to protect against that as well. What's interesting is this is really defense in layers. If you can prevent the malware from getting downloaded, if that gets missed, and then that malware starts doing a whole bunch of things like encrypting files, that would be suspicious activity. That would not fit into the behavior model. So you actually you want a system that has these layers of defense where you actually try to prevent all the malware from coming in, and if malware does come in, you basically block it because it ends up creating a lot of suspicious activity. But there's other attacks besides virus and malwares. I'm myself have read about an attack that was pretty clever, and it would your server defenses would not cover this. A lot of people think they can protect the perimeter of their application, their endpoints to like let's say it's an internet-facing app, and then that's sufficient. Unfortunately, many attacks come in through the application. So the attack I heard about was pretty interesting. There was a bug in an application component that basically allowed someone from their web browser to put in through an injection attack and run any script inside any of your containers through the app layer. So it looked like normal application traffic, so it did not get caught by anything outside of the network. Once they did that, they actually launched containers on that node, their own containers, that attacked other containers within that node. So they're having an attack within inside a server that's not detected outside of that server. So these are the kind of defenses that would cover that attack. Oh, very good. Yeah, I like that. Yeah, so the idea here is you want the defense in layers, you do want to protect as much possible your exterior perimeter defenses, but you need defenses inside. You can imagine, like, I don't know if any of you, I worked actually, I had a top secret Q clearance, and I worked in a high secure environment, and I needed my badge, and they checked and they scanned it when I came into the area. But I couldn't just, because I got in the area, walk into the vault and get all of the tapes of the backups. I had extra security everywhere I went. You got to think of the same thing. You cannot depend on just perimeter security. Okay, so let's talk a little bit. We've talked about the negative. Let's talk about how we solve this problem. One is integrate your security into your CI and deployment. So what this is about is basically security vulnerabilities that might make it into your container. You want to catch those early on. You want to catch those on the developer desktop. You want to catch it during your build. So you want a process of producing basically secure containers before they get deployed. And obviously, you would want higher protection for a customer-facing, internet-facing container than you would for one that wasn't. So you want a custom policy for each of your apps. And then you want a policy that automates, basically it's a here is to have defenses in place that protect you at every point in this kill chain. And you say, why every point? If you can cut off one, it's done. But the idea is if somebody's clever enough to get past your network defenses, you can. I think I have time for questions. So please, if you have any questions, shoot them my way. Any questions? Okay, well, please come by our booth. We have some giveaways as well, and I'll be around if you do think of any questions. Please come and visit us. We have a few people from U.S. Bank here today. They're one of our customers, so I'm glad they made it. Please come and ask me about how we can help you. Thank you.